Mr. Mok Sharma and Mohammed Al Homzi, and I'm joining us from Danfoss. Welcome, gents.
Good morning. Good morning, everyone. So my name is Muhammad Ali. I'm heading the sales for TMA, Turkey, Middle East, Africa, from Danfoss high pressure pump segment.
And my name is Amok Sharma. I'm Global Application Marketing Manager for water reuse application for Danfoss high pressure pumps based out of Denmark.
So first, thank you, Marsi team, for the whole week. I mean, pleasure to be here with you, Mr. Pierre. Thank you so much for everything this week. Just to make it a bit interaction. So we will start with a question for you, Amog.
Yeah. So, I mean, this whole week has been great and we have eaten a lot of meat, a lot of burgers. So, a question, all of you, how many liters of water does it require to make a hamburger? Anyone? Yeah.
Yeah.
Anyone else?
Yeah. Huh?
So, so it's 3,140 liters. Yeah, a lot.
So yeah,
And most of it taken by the beef patty.
the beef, yeah, bun,
Yeah.
lettuce, tomato, cheese, bacon. If we need to add bacon, so yeah, it's
And this reminds, the water stays. We had a great conversation with peers, I think 2 days back, where we discussed that water stays there. It's not evaporating. It's not going anywhere. It's on the earth. But we ourselves are reducing the available fresh water. And that's why we all here as well.
Yeah. So we will go through a bit about overview on Danfoss group overall, and then a bit on we will touch on the product side. So Danfoss is the leading technology partner for the green transition. So our key focus is desalination, water reuse, and industrial water. We do manufacture high pressure pumps and energy recovery devices. And from our experience, we have up to 29,000 SWRO worldwide for water reuse and seawater RO application. So about Danfoss, we are a group of more than 39,000 employees located worldwide in all the continents, and our global sales is around 9.7 billion euro. And that's the whole segment. I mean, and Danfoss still is a family-owned business with the third generation in Denmark. We cover the whole continent, Americas, Europe, and Asia, and our most sales is coming from Europe. The business segments for Danfoss, we have power solutions, we have climate solution, and the drives. So the contribution of each segments in percentage here, and we are part as a Danfoss high pressure pump under the umbrella of climate solutions. On our application or our customers globally, so we deal in desalination, water reuse, humidification, flat panel cleaning, firefighting, and gas turbine. It is based on the axial piston pump technology. And from application to application, just we have some differences in the material. Our APP, we call it our axial piston pump for the high pressure pump. And we have our ERD, we call it iSave, energy recovery device. It is a device, ERD, motor, and booster pump in one body. And we have the active pressure exchanger. It's also, we call it motorized pressure exchanger, ERD plus motor. So our APP which is the axial piston pump. We can see in the picture here, we have a pump on positive displacement technology. In efficiency, up to 92%, 90% or 89% minimum at any point. It's a simple design pump and easy to use. It's made of duplex, super duplex, and in most of the cases, we have it in fully super duplex material. And the range of the APP, we can start from 0.6 meter cube per hour up to 92 meter cube per hour as a single pump. So some improvement on our pump. We call it the ceramic pump. So we have some improvement. We changed the peak material to ceramic pumps, and then we like that we can save in terms of pre-treatment cartridges. So some improvement. What happened in here that we can use the pre-filtration with 5 micron nominal standard filtration and a longer service interval. So our basic pump or standard pump, it's up to 8,000 hours. And then now we double it to 16,000 hours by changing some of the components from peak to ceramic material. Maybe we can see the next page. So, want to add something on the ceramic?
So we are very proud of this, first of all, because it's an award-winning pump as well. We won an award in EDS 2 years back. And since then, we have around more than 50 installations worldwide so far for both desalination and water reuse. Coming back to this point, so the key parts, the valve plate, the port plate, and the source plate, that are the major wear parts of the axial piston pump, are changed into ceramic components. And the pistons are hardened. So it is perfect for the, especially a very demanding harsh water, especially when it comes to water, industrial wastewater, and it's also available in different ceilings to accommodate that harsh water conditions.
So a question also here, and how we need to jump to what value we are adding in the let's say water treatment business, especially when it comes to the high pressure pumps, and what is the difference between our axial piston pump and the centrifugal pump? So next for you, Gamok, also.
So normally what we have seen, when we are designing our plants, our systems, we are looking at this different, pressure, flow, and whatnot. And, we design it, and then we based on that, we choose the actual or the pump and the energy recovery device. But those conditions are constant, but the world is not constant. So the key benefit that you get with an axial piston pump compared to a conventional centrifugal pump is consistent high energy efficiency across the flow, irrespective of the flow and the pressure change. So the efficiency is independent of the flow and pressure, and you don't need to have any extra comfort margins in the system curve, and you can design your system without worrying on looking at the best efficiency point for the centrifugal pump. And you can just design it, and that gives you design and operational flexibility as well.
So an example, if we are designing a 10 meter cube per hour flow on 10 bar, we can get the 10 meter cube per hour, and on 80 bar, we can also get the same flow. So it depended axial piston.
Yeah. So this is what we have seen for one of the example. This plant has been running for 4 years already, and there has been a lot of flow and pressure variance, but the efficiency on the has been constant. That has been 91.6% there. And this is what we have learned from our customers, end users, that the key value that what they value the most is the highest efficiency, because that not only reduces the cost, but also reduces for the end users the CO2 emissions, which is also contributing to meeting their climate goals. So as I said, so the more everything is constant when we are designing in a static. The electricity price, the permeate production recovery rate, and the seawater temperature. But in the real world, the world is not static because the membrane pressure is changing across the season. There are daily electricity price variation because of the geopolitical situation as well. And the water demand variation is also changing depending on the rainfall or how much water they want to produce. But this impacts the total system efficiency. So here we have, based on these two scenarios, a static and a variable, we will show just a quick on what are the impact on the savings that you can have with the axial piston pump compared to the centrifugal pump. So when you see from train size to 500 to 10,000 CMD plant, the if you look at the constant condition, that is the that is the brighter red, you see you have a lower savings, or in other words, in the static in the variable changing world, you see even more savings of cost versus the conventional technology of centrifugal pump when you use an axial piston pump, because the energy efficiency remains constant irrespective of the flow and the pressure or any of these external factors. So, Homsi, you want to?
Yeah. So just back to the APP or the axial piston pump that we have it. I mean, in here we can see the easy disassemble for the pump and how we maintain the pump in the regular maintenance. So in here we can see the pistons and the spring cartridges and again the assembly where we have it. So it's a few moving part and really a small footprints for the SWROs or the plants, even in containerized or land based. And then the easy to service. I mean, on site, it take few hours. And Derek here also he can he have the most experience on our pump on site. You're smiling, so it's easy or it's a hard one? Easy one. Yeah, yeah, yeah. So yeah. So in conclusion, I mean, we have a value in our pump in this, and we're coming with a 30 or 35 years experience. Our pump is made in Denmark, our one factory in Nordborg, near the HQ, Danfoss HQ, and we always speak efficiency in pumps. And then next we will see the ERD, what we've been talking about. So we have two type of ERD. The first one, the iSave, and it's a patent technology from 2008. And the first field application it was in 2009. If we need just to give you an idea, our iSave mostly for containerized application, more or less. And then we can start from 200 meter cube per day plant until 3,000 meter cube per day, which we can fit the APP pump plus the iSave. And when we spoke larger systems, we prefer to go with the motorized pressure exchanger. So the booster will be separated. It's the same device, but we remove the booster pump from the iSave, and then it will be separately like a isobaric system. And we have more than 15 years in experience and 3,000 worldwide references with our ERDs. So the models for the iSave, we have 4 models, and it depends on the reject flow that we have it. So iSave 21, it is a 21 meter cube per hour reject, and then up to iSave 70. It's a fully super duplex material on the high pressure and wetted part. And as you can see here, pressure exchanger, the booster pump, and the electrical motor. And it is a VFD driven. So It's an integrated solution. I mean, 3-in-1, compact. It can be installed horizontal and vertical for saving for the footprint. I mean, how the iSafe work, we will not go a lot in detail, technical, but that's a device that it can get the brine or the high concentrated flow into a pressure exchanger, and then we pump it back to the same line, so we can save up to 50 to 60% of the power consumption of the SWRO plant. So just a comparison, because in the market we have the isobaric pressure exchanger, and on the left side we are seeing the iSafe. So in here we can see more component needed as a pressure exchanger, motor, the super duplex material, and the high pressure flow meter. And if you compare it to our iSafe, it's a one product. It can replace the whole set on the right side. That's an idea about the motorized pressure exchanger. Typically the same in terms of efficiency, in terms of material of the iSafe, but motorized without a booster pump. And that's we use it again for the larger system. In the MPE 70 or iSafe 70, we prefer to have the motorized side to have the benefits for you on the market, on the control. It's purely a control based, VFD driven, protecting your system. And in terms of material, it's a super duplex material.
So just before we go to the next slide, a question or sort of something for you, Homzi. We have up to 92 cubic meter. So what if you want to go for the mega plants, like in the region, especially which you are handling?
Yeah.
How would you?
So instead we have a limitation in our pump up to 92 meter cube per hour. When it comes to larger system, we design our system to go with parallel systems in terms of pumps, and this will give you a lot of benefits in terms of let's say we call it no pump, no water. So when you have two parallel pumps, I mean, you can cover your system, and you have a compact design more to control the efficiency and the design. So in here we can see two examples. In the first one, a centrifugal pump plus booster plus the pressure exchanger. In here we have a 1,200 meter cube per day to 2,000 meter cube per day. We can see a single pump plus two iSafes, and the footprint is dramatically saved in here. I mean, the example next, maybe, yeah.
To add, so when we have more parallel pumps, 2 to 3 or 4, so this also gives the flexibility of whenever you want to have less water, or if one of the pumps gets, there's a unforeseen situation and it's not working, but then you have the other pumps to work. Whereas in the centrifugal pump, once the pump is down, then you have to either repair it or change it. So you lose that hours of production of permeate that you really need. And this is just an example of this train size of 5,300 cubic meter per day, where 3 APP pump with 4 iSafe 70 can be installed. But you can, of course, the beauty about our products is that they are compact. So you can fit it in a container, and you can actually, if you want, let's say, more water, you can add extra modules. So you don't need so much of infrastructure to build. Rather, you can have containerized systems where you can just add it just like Lego. So yeah.
And that's a 16,000 meter cube per day. So per train is around 5,000. And just at the end, we have a 4 core technologies that it can support you in the design of the plants. So we have pumps, ERDs, variable frequency drives and the sensing solution. So it's a 4-core technology that we can really be a partner for you in the design stage. So in time's up,
Yeah.
but thank you so much.
Thank you so much.